Hi, are you attending the Plutus Pioneer Program about Cardano smart contracts and you've just completed the lecture about monads, but after following the full lecture you're still confused about what monads are and how to use them? Well, I'm glad you're here, because today what we're trying to do is to try to learn how to think about monads instead of just trying to understand what they are. Because I think, based on my experience, if you start to get familiar on how to use monads, then you can understand what they are all about, and with the time to master the concepts and what are they based upon. So I am Giovanni, also known as CryptoJoe101 on Twitter, and I am a stake pool operator. You may know, if you follow me already, that I've recently quit my job, and here there is a link to the video in which I announce it. So I'm currently looking for support, and the best thing to do is delegate to my stake pool. That is the easy one. That is the easiest way. So if you feel to support me, please just delegate to my stake pool. That would be fantastic. I am also Plutus Pioneer, and I've been following all the lectures. And today, for the first time, I will step a little bit outside my comfortable zone, and I will try to leverage my 6 years experience programming in Scala in trying to put a little bit of clarity into what monads are and how to use them. Actually, only the second part, the former, I will leave it to specialized people that I don't feel like I'm part of. So yeah, so let's start. Let's get ready. Here is the definition of monad. So before starting, actually, I just wanted to say something. I think Lars did a super amazing job in explaining what monads are, and he slowly built on the concept that he was explaining during the lecture. And I think at one point what I really thought was that the concept of side effects was somehow related to the concept of monads. Based on my experience, and please someone correct me if I'm wrong, the two things are quite unrelated to each other. As in, monads, they don't really care about side effects, even though in Haskell, as in another programming language, side effects are elegantly managed by monads, but that doesn't mean that monads have been invented or are something caused or related or somehow due to side effects. Side effects is something a little bit different. It talks, in fact, Lars spoke about that one as well. It refers to referential transparency that I invite you to read about, because it's a fantastic concept. It was completely new to me. So here, what we are talking about is actually is kind of an abstraction that is not related anyway to side effects. Side effects is, I think, in my opinion, so from what I understand, is something completely different. So let's start from the definition of what a monad is. I'll just took this one from Wikipedia. I increase a little bit the character, the font, and says, in functional programming, a monad is an abstraction that allows us structuring programs generically. Supporting languages may use monads to abstract away boilerplate code needed by the program logic. Monads, and this is, I think, important, because here is like literally if I want to use monads, what do I need? What do I really deal with? So monads achieve this by providing their own data type, a particular type for each type of monad, which represents a specific form of computation along with two procedures or methods or functions. And this is paramount. One that wrap values to any basic type within the monad, yielding a monadic value. Another to compose functions that out monadic values. So you can think about it like a monad, just saying it very stupidly, is a class and has two methods. In Scala, they are, for instance, called apply and flat map. In Haskell, they are called return, that is the equivalent of apply, and then bind, that is what in Scala would be flat map. The first one, return, basically takes whichever value and wraps it into a monad, and so that we have a monadic value. And another one that is the bind, that basically allows you to compose function that output or return the same monadic values. So these are the two fundamental concepts that have to be respected. Well, there are many, but practically these are the two aspects that you have to focus about in order to deal with monads on a daily life. So let's start with a little bit of an example, right? Let's say that, for instance, we have a database, and the database has two tables. A table with users and a table with addresses. Each user has a user ID, a name, and an address. And the address is basically just like an address ID and a string, like the actual address that is a simple string. Now, of course, for a given user ID, the user may or may not exist, and for a given address, the address may or may not exist. So, in this example, what we are trying to do is to use the concept of something being optional, right? So that may or may not exist. So what we try to do is look up for either users or addresses, and we try to leverage the so-called maybe monad to deal with the fact that the user or the address is optional. We will start from a very basic example, and then we will try to make things a little bit more complicated and see how monads help us to compose multiple functions or multiple pieces of code of the same monadic value in order to make the code a little bit simpler. So let's start from the top. We import the list. This is for the next example. Sorry, forget about that for a moment. So we created the two data objects now. We create a user, and as I said, there is a user ID, a name, and an address. We're deriving the show type class so that we can print the result on the command line. And then we create the address type with the address ID as there was a user ID and the address itself. So, and then we create a very simplified version of what database tables are, basically two lists. And we say that there is the user 1, Joe, with the address ID 1, the user 2, Charles, hello, Charles Hoskinson, this is for you. And the address is number 2, and the Vitalik Budarin. How's it going, man? But you don't live anywhere because your address does not exist. In fact, we only have address 1, that is Ireland, my home. And then address 2 is Colorado, sunny Colorado, for where Charles Hoskinson lives. So let's try to find a username, right? So we know that the username, so the name of the user of a specific ID. So we say that we want a function that is find the username that takes an integer, and it's basically the user ID here, and gives us the name of the user, that is this attribute here. Now, of course, because I haven't put all the possible integers of the world inside this list, there is a chance that the user may or may not exist. So what I'm saying into the signature is that for a given integer, we are maybe returning a string. So this could be, we could potentially find a string, or we could maybe not find a string. Actually, let's start from this example first. I think logically this makes a little bit more sense. Let's do this one first. Apologies for this. Let's find this is in fact not bind. This is just find user, right? So we say that for a given ID we try to get the whole user, right? The whole full object. So this one or this one or this one. So let's switch into the REPL, and the name of the method, the function is find user. So we go into the REPL, and we have, okay, we're already here. So we load the module. It's called the monads, and then we try to do find user. So let's see that the find user is actually in scope, and yes, it goes from int and it turns maybe user. So if I do find user 1, this is me. If I do find user 2, this is Charles. 3, this is Vitalik. 4, we get nothing. Just to be clear, let's notice how the just is wrapping the actual user, right? So this means that the computation ended up properly, and so the result is wrapped. And again, here the concept of monad is there is a value, there is a something that is wrapped into the monad. Even in the case of nothing, we're still getting a monad distance back, but in this case it's empty because there is no monadic value inside. So right, so we're starting to think about this thing, right? So there is a kind of a type that is the monad, and then we can put stuff into this monad that is in this case is user, but it could be an address. So if I say find address 1, sorry, maybe to S, this would be handy, and we say just address Ireland, but if I do 2, it's Colorado, and 3 does not exist. So this is exactly the same. As you can see, this is still just. So, and then there is I think it's called the type parameter within the monad that is actually address or is an actual user. But let's forget about that for a second. So we see how we can maybe find, maybe yes, maybe not finding something inside this thing. So let's complicate a little bit the things. Let's go back to the find user, right? Find user 1. Now, basically what I found is that what I want is that whenever I find the user, I want to build another function that just doesn't matter, doesn't care about finding a user, but I want to know the name of the user of the that has user ID equals to number 1. So already here, we are going into another very important concept that are functors. I'm not gonna say a word about functors, but I'm just gonna put the name here, because if we are dealing with functors, it means that we can do something on the fly. So there is an additional behavior that we can do without getting out of the monad, but we can change the content of it. So let's just do the example first, and then I'll give a little bit more explanation. So I was talking to about this like just a minute ago. So what we do is that we still use the find the find method. So the find method is nothing else that we scan through the list, and then we have a small, so it's a find, and then the list is users, and then we set the function here. This is a lambda function, and the way the syntax is a backwards forward slash or something, and then we say that the proper user ID of the variable a, like we should really call this u, as in users. The user ID is equals to the ID that we just passed, and then we have to scan through the users. Of course, if we want to just find the user, this is enough. But if we just want the username of this user, what we have to do is to change the content of the maybe monad on the fly without getting the value outside the monad, if you know what I mean. Like the monad is wrapping this thing. That's the reason why lots of people say that monads are burritos, because like they are wrapping contents, right? But again, forget about that. So we have something that is encapsulated in a monad, and we know that is a user, but we don't care about the full user, we just want the name. So is there a way we can change the content and just extract the name and just without ever getting that value outside of the monad? Yes, we can do that. And this is called fmap. Fmap, if you are familiar with the probably like majority of the languages, they have a function that is also very popular for lists. It's also usually called the map. That is basically change the type of the list from this type to the other one. So in this case, what we are doing, we are just extracting the name from the user object. And apologies, maybe in Haskell these are not considered objects. These are actually structs, more like structs, so I don't know, but at the moment I'm going to be calling them object as I would call them in Scala. So what we do is that we define the maybe user here. This could be find, this could be not found. And what we say is that, so we use the let user be find blah 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 from the users list, and in return from the user that we've just taken, fmap, so basically map, more familiar, take this lambda expression and extract the name from the user. Now, look, in this in expression, we don't care and we don't know whether or not the user actually is a just or is a nothing. But the beauty of the monads is that if by any chance we are in the worst case scenario, so for instance the user is not found, this is resolved for us, and this extraction is not gonna happen because we can't map an empty value. So we don't have to say if result is empty or if result is not empty. What we can do is just you take the value back, and if the value is there, just map it and extract the name from the user object. If the value is not there, there is nothing we can do, so just return nothing instead of just something. Let's try it out. Find user name. We go from 0. Oops, what's the name again? Find username. Yeah, sorry, that was a typo. Nothing, and then 1. Look at this. Now, instead of being just user 1, Joe, and 1 again, we look at this. We got the user exactly the same code, right? But then, without ever getting the result outside of the monad, we changed its content on the fly. And this is really, really important because whenever we are using more complex monads, like for instance, a monad that is dealing with the input and output, for instance, not the company input output HK, like the proper side effects we were talking about earlier on. We are reading from files. We want to read something and change its content on the fly as we read. Instead of getting these results outside of the monad and then maybe load everything into memory, we are doing this thing on the fly. And this is the beauty. If you have a monad, so it means that a monad is also a functor, what you can do is change the content on the fly, right? So this is the very first good thing. So if you want to change something, if you want to map or functor map something in a monad, if you have a functor, a monad is a functor, you can change the content of the value encapsulated or captured by the monad on the fly. Right, and if I, as I showed you earlier on, if I go find username 6, there is nothing, the map is not, the function map is not exploding, it's not giving me an error because it's done by design that if there is nothing into the monad, I know I've said it 10 times, but I want to say it just one more time. If there is nothing, that the beauty of the monad is like, that's failed, I can't transform anything, so nothing is nothing, there is nothing inside. Right, so we have done the example of the address. So we found the address as well. So let's do the address again. Find address 3 does not exist. 2, it's Colorado. Right, now we've talked about the first of the two things about monad. So the return, the apply, the thing that you can capture a value and just whichever value and just put it inside the monad, right? Now into the documentation says that we can concatenate things. So imagine this scenario exactly for this type of exercise we are doing. Now we want the address of the user with the user ID 1. So what we do is basically we do find user by ID, we set find user 1, but then take the address ID and immediately after take the address and return it. Now we have two operations here. The first one is get the user that could exist or could not, maybe exist or maybe doesn't exist. And then if he exists, get the ID, address ID, and then go again on the database and get the address that in this turn could or could not exist. So this is like if you're doing this programmatically, get user, if user exists, get address ID. If address ID exists, fetch the address, and then if the address exists, show the address. So there are like 6 ifs. Wouldn't it be fantastic if we could just concatenate those two things one after the other? And because the first thing is the user, right? It's a maybe, and then the second thing is an address, and itself is a maybe. Can we just slap those two things together and just like make one call that the results is anyway a maybe? because maybe the user does not exist, or maybe the user exists and the address does not exist. But I don't care. I'm only care whether or not the address exists. That's it. Can we put those two things together? Well, there is this one thing that is in Scala, it's called for comprehension, and I just can't remember. Like, I read it before this tutorial and I forgot the name. But we do have exactly the same in Haskell. And the beauty of this thing is that it's basically just going through the happy path. So you can think of flat mapping monads, binding monads. That is the second of the two methods. In Scala, it's called flat mapping. In Haskell, it's called binding. So what we are doing is that find address by user. Really, this should be by user ID. Here, just like this is the proper thing, right? Let me fix this one for you. So basically, what we are saying is that we just put the user ID here, and then we don't put also the address ID. We don't care, because we're gonna find maybe the user, and if maybe has the address, we're gonna get that ID and pass it that on the other function to find address. As you can see, look, we have find user here, find address here. We combine the two things, but we haven't done any result as like, is this maybe, is this just? Say, do me a favor, find the user ID of this one, and then put the result here. Then bind this thing to the next operation, right? And say, then from the user, extract the address ID and pass it to find address. But look at this. If the user is not defined, this call will not be made, because I think the correct way of saying this is the bind is basically making a short circuit for this thing for us. And so this operation, like the if, is not even executed, because if the user does not exist, this one will not be evaluated. And so nothing will be returned straight away. While if the user exists, the address ID is correctly evaluated, is passed to find address, the address is returned. No, this address could either be just the address or could be nothing. If it is nothing, we get nothing again. If it is just something, we will get the actual address. Let's see this thing in action. Find address by user ID. So we know that I am Joe and I live in Ireland. Boom, there you go. Let's see if this is correct. I am Joe, and my address, that is the last param, is the number 1, and this is address. Let's see, where does Charles Hoskinson live? Is user number 2. Colorado. Fantastic, this is working. And now let's check user number 3. Vitalik lives in the Ether, so it does not have an address. So, boom, nothing. And look how beautiful the code is. 3 lines. We are not checking if this is nothing, if contains something. In Scala, we have option that is exactly the same as maybe. If you want to do this in a procedural way, you should do like a get the result. Is this null? Is this empty? Does this thing exist? And then if. Monads allow you a fantastic way of concatenating functions or objects or values that return the same monadic type. Find user returns a maybe. Find address, even though the type is different, string and user, but address and user, but it's two maybe, right? So if I have a function that can translate from user to address, I can concatenate those two instances of the monads together by just passing a function that is the find address that is able to take a user ID and transform it into an address. And this is basically 3 lines of code for dealing with the very complex thing that is check one table, then check the other table, and then if there is, return the result. So I've already pasted something, the URL about the definition of the monads. But now let's do another thing. This is mind blowing. Like whenever I was studying Scala for the first time and I had this example, this is when like a flat map clicked into my head. Let's make an example, right? You have 5 files that files like documents, and the document contains text, and the files are named file 1, file 2, file 3, file 5. And now every file has text inside. File 1 has 1 line, file 2 has 2 lines, file 3 has 3 lines. So this is just like to make a simulation, right? So, and now I want to read all this content in order, and I just want like a big list, right? So I want to list, I want to read all the files, and for each file I want to list the content and put it in just one big list, right? So if you understand what I'm talking about, if file 1 just has 1, and file 2 has 1, 2, and file 3 has 1, 2, 3, and so on and so forth, I want basically a result that I want 1, then 1, 2, and then I want 1, 2, 3, and 3. The last one, this is 1, Jesus, 1, 2, 3, 4, 5, right? So it's like read all the files in order, blah, 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 concatenate in just one list, right? Fantastic. Like, if you are like me, I'm sure you're much more clever and intelligent than me, but like, I was a little bit silly at the beginning when I was studying Scala, just like, let's read all the files. So what I was doing was like, files, is it like files 1, 2, 3, 4, 5, right? So what I wanted to do was like, I need to read the content of the file, so I need to map that content into something else, right? So I was like, so I have to compose those two things. So it is fmap, and it was my read the file, actually, and then files. So and then there is another function file that takes the name of the file, that is just the integer here, you see, like passing 1, and then returns the content of that file, right? So I read the file, and basically what it is just like 1 to n. I think I can remove this. So just an example, if I pass the file name number 2, what I want to see is 1 and 2. As simple as that. So this is what this is doing, right? And if I'm passing 4, for instance, this is returning 4. Right, so let's see what happens. Oh my god. I should have thought about this. This is returning a list of lists. If you think about it, it's fine, it's correct, because the fmap is replacing every occurrence of the indexes with the content of the actual file. So file number 1 only contains 1, the file number 2 contains 1 and 2. Guess what? How can I have all those things in just one list? Yeah, you got it right. I need bind or flat map. So now, in order to do this, I need to change a little bit things, because what I want to do is files, and then the bind is this symbol, and then is my read file. And there you go. There you have it. Does it make sense to you now? What does concatenating means? So I have a first computation that returns a monadic value of a monad of a certain type, and then you have another function, in this case my read file. Look at this. This is taking one integer and is returning an array of integers, and this is already an array of integers if you think about the type. Look at the type files, right? So you can think about files as something that gets from nothing to integer, so monad of integer, right? And then for every single integer within the array, we generate another array of integers, and then I just want to combine those two things and just make like one longer array. So what do? I do files bind my read file. And so instead of doing the map that is doing like a 1 by 1 element substitution, I just want to take all of them and I just want to do one long string. So this concludes this small tutorial about thinking about monads. I want to prepare something also about reading and writing, so with the write type param and with the writer monad and the reader monad. But this is my first attempt at try to forget for a second what monads are and start to think how to deal with monads. Because if you start to mess with them and start to play with them and you know how to compose monads, then you understand more about what they really are. Because unless you have a little bit of a stronger category theory background and a stronger mathematical background with this concept about category theory and how these things are combined together, at least as it worked for me, like I never fully got what the monads were until I started to use them and play with them and understand how to combine them. Right, we're getting towards the end. My name is Giovanni, also known as CryptoJo101. I'm a Plutus Pioneer and I'm also a stake pool operator. If you like this content, first of all, hit like, subscribe for more funny things about the Plutus Pioneer and Haskell, And then please delegate to my stake pool. The ticker is easy1. I would love to see the number of delegation growing so that I can focus on my work. That's it. Thank you very much, and I'll see you around.